Next, consider the tangent inverse of x. We know that this is the antiderivative, the integral of 1 over 1 plus x squared. Okay. And we know that 1 plus x squared can be written as 1 minus x squared. Right? And that's the same thing as integration, sorry, the power series, right? The power series of, counting from 0 to infinity, and it's minus x squared to the power of n. Okay. So let's find the antiderivative of this. Okay. Okay, so actually to make it more obvious, let me expand this sigma out a little bit. So when n is equal to 0, we get 1, right? When n is equal to 1, sorry, you get a minus x squared. When you get 2, you get a plus x to the power of 4, then a minus x to the power of 6, right? And then you get a plus x to the power of 8, and so on. Pattern continues. Okay, so that's going to be an x minus 1 over 3x cubed, 1 over 5x to the power of 5, okay. Oops, okay. I already actually found the integral, so you got to remove the integral sign. Okay, with some potentially some constant at the end. Okay, so this power series function, it can be just written as, okay, so let's clean it up again here. X goes up by all power, so that's x to the power of, we can say it's 2n plus 1, right? 2n plus 1 over same 2n plus 1, 1 over 2n plus 1, n is equal to 0 to infinity. Okay, that expresses all the terms except for the sign here, so we gotta make the first one positive and the second one negative. So when n is equal to 0, right, if I put n there, it's going to be positive, so this is perfect. Okay, so how do you find this constant? Recall that this is equal to tangent inverse x. Okay, and we know that tangent inverse at 0, it's 0, so let's replace all the x with 0, so this whole sigma expression turns into 0, and this is also 0, so c is equal to 0. Okay, so therefore the tangent inverse in power series representation is counting from 0 to infinity, minus 1 to the power of n, 1 over 2n plus 1, x 2n plus 1.